So our learning intention will be how to apply various concepts of right-angled trigonometry. You have seen much of this. Some of it will be a little bit new. Without further ado, let's take a look. So you need to be familiar with vocabulary. Vocabulary is angle dependent. This is what that means. When I'm looking at angle A, BC would be the opposite side, and AC would be the adjacent side. If I am looking at angle B, then this is my opposite side, and this is my adjacent. And the way you figure it out is really simple. Adjacent means it touches the angle. Opposite means it's on the opposite part of the triangle, and it does not have any side in common with that angle. These two only refer to the legs of the triangle. In other words, the two parts that form the right angle. Hypotenuse is always opposite and the longest side. This is all these stuff that you know. If you didn't, well, you just got a quick lesson from about it. Sine, cosine, tangent. You should be familiar with this symbol. If not, make a text box right above it. That is called theta. That is a Greek letter. If you go to your equation editor, all the Greek letters are on the top two lines. It is at the end, right before pi. So we will be using that from time to time. Some old hippies caught another hippie tripping on acorns. So that is the school appropriate version of it.
Tripping on acorns.
Sure. If you've ever walked on acorns, you could definitely trip on them. All right. Remember, we're being recorded. All right. Sine F. The opposite side is, and you're going to notice that I label stuff frequently, just with the first three letters, OPP and ADG, opposite, and then I color code. So angle G, it's exact reverse. This is my adjacent side, and this is my opposite. Regardless of which angle, this is always my hypotenuse, always opposite to the right angle and the longest side. So taking that into account, we're going to fill this in right here. So sine is opposite over hypotenuse. So 32 over 40. Okay. Let's move this down a little bit. And then let's move it over towards the end because we're going to make an equal to sign. Everything can be simplified. We're going to simplify them a little later. Okay, so tangent of G. So I'm looking at the purple one. Opposite over adjacent, so 24 over 32. So 24 divided by 32, and again, let's put a little equal to sign. We're going to simplify those a little bit later. You figure out cosine of G and tangent of F. Remember, it is angle dependent, so these are not interchangeable. If you can find those last two, and then if you want to, you can simplify on your own or wait for the rest of us. All right, Logan, what do you got for cosine G?
32 over 4.
Okay, so G, adjacent over, oh, that looks familiar. We'll talk about that in a second. My clicky's not clicking. There we go. So one more time, Logan, was it?
32 over 40.
32 over 40 equals. Denise, what do you got for tangent F? One more time. 30. Oh, not dictionary. 32 over 24. Now, here's a nice thing about right triangles. When you work your way through them and you're simplifying, your GCF is going to pretty much the same. What's GCF going to be there, Leslie? 32, 40, 24. There's a GCF for all three of those numbers. Marco, help her out.
Is it 9? No.
9 doesn't go into any of these.
No.
Really close.
Wait.
8.
Let's go.
Okay.
Oh, I knew that.
So we're going to divide each of these by 8. I'm not going to show all the rest of the arithmetic. Okay? So 32 5. You do the rest. Simplify them, dividing top and bottom by 8, and then scroll to the next page.
I didn't give you the answer because I was pushing. You should have
1.
America.
America.
Divide by 8. You got 3/5. Divide by 8. Hey, that one looks familiar. Sine of f is the same as cosine of g. Yes, and we'll be discussing that a whole lot more. But tangent of f isn't the same as tangent of g, but they do have a relationship. They are reciprocals. So these are equal, and these are reciprocals. Yo.
Yeah.
Does that make a boo-boo? Yep.
That's a big.
So this is 3/4. Thank you. And this is 4/3. Okay. Everything else looks good. All right, next page. Speaking of reciprocals, these are reciprocal functions. So let's see, hypotenuse over opposite. That sounds familiar. What else has hypotenuse and opposite? Which part? Sine, cosine, or tangent?
Tangent.
Sine. So instead of hypotenuse over opposite equaling 1 over sine, we have this new thing called cosecant. But we're going to write it also as a reciprocal. So in the white space to the left, write 1 divided by sine. Notice it's theta. So go to the pi symbol. Towards the end of that first row is theta. And you're going to write a little equal to sine. So 1 over sine theta is equal to cosecant. I'm just going to line this up a little bit better. So that's the reciprocal function of sine, it's cosecant. What do you think might be the reciprocal function of secant?
Sine.
Nope, we just did sine.
Oh,
The cosine, because it's adjacent over hypotenuse. I'm sorry, hypotenuse over adjacent, so flip it. Notice, when I type C, it's a variable. O, it's 2 variables, but when I type that S, see how it's italicized? Cami understands that that should not be cosine. And the next thing I type, it'll put a little space and make that theta back into the italicized. Okay? So that's cosine, and cotangent would be the reciprocal function of tangent. So 1 divided by tan, also theta. Okay. And just move it back over to the left a little bit. I don't have a mnemonic. I don't know where they got this from. I don't chop hot onions. That hurts my hand. So I just remember the reciprocals of these. Oh, that really restricts what you can eat then.
It's not really.
Yeah, literally. If you're a bee.
All right. So again, I'm going to color code, and this time I'm actually going to use the colors that they have. So F is blue. This is still opposite. This is still adjacent. So use the definitions on the previous page and fill in these 6. The numbers are going to look familiar because they're the same. Questions on these 6? A couple things to notice. With sine and cosine, your answers are always less than 1. But for secant and cosecant, they're always greater than 1. So if you ever end up with a sine or cosine greater than 1, you know you made a boo-boo. And if you make secant or cosecant less than 1, you made a boo-boo. When we start graphing these, this will make a little bit more sense. All right. We talked about these briefly last week for those of you that were here when I talked about these. If not, that's okay. I'm going to go over it again. So a 30, 60, 90 has these specific ratios in place. So it's a little confusing with variables, so we are going to throw in some numbers. Okay. Jerry, pick an even for me. Any even.
Even?
Mm-hmm.
12.
12. So if I have 12 as my hypotenuse, you can see this is 2x. I want 1x. So I take half of 12, and that's 6. So my shorter leg, which is adjacent to my 60-degree angle, would be 6. My longer leg is always my shorter leg times the square root of 3. So in this case, 6 square root of 3. That's it. Pick a different even number, Torah. Okay, so y'all are going to finish this one. Replace the 12 with a 4 and find your short leg and your long leg. So put 4 in for your hypotenuse. Let's see if you can do the rest. What's the short leg going to be?
Huh?
Short leg?
Oh, just the random number? No, you did the
Torah told that the hypotenuse was 4, so the short leg is?
Oh, 2.
2. And then the long leg is always whatever this is times the square root of 3 every single time. Okay? So it's pretty easy unless I don't give you an even number for the hypotenuse.
33.
So what happens, I won't make it super hard if we give you the long leg. Okay? And I'll make this relatively simple. Give me a multiple of 3 bigger than 12.
16.
27. Okay? Because 16 is not a multiple.
Wait.
So now I have to go backwards. It's going to get a little harder. Okay? In fact, I'll make this look a little prettier because this is going to have a lot of work in a minute. So if I make my long leg 27, instead of multiplying by square root of 3, I got to divide. Okay, so to find my short leg, I say 27 divided by square root of 3. Root of 3. But I don't like square roots in the bottom. I have to eliminate them by multiplying it by a square root of 3. I'm going to need some more space here, so I'm going to move this up. But whatever we do to the bottom, we do to the top. So I'm going to multiply top and bottom by square root of 3. Bless you. But on the bottom now, we don't have a square root anymore, right? Because square root of 3 times square root of 3 is square root of 9. And square root of 9 is, and that was the whole point of multiplying by eliminating. Okay? So now I got 27 square root 3 divided by 3. But 27 divided by 3 is 9. So my short leg here now is 9 square root of 3. Which means my hypotenuse, if I divided to get the short leg, I multiply by 2. So 2 times 9 is 18 square root of 3. Unless I specifically tell you to round, keep everything in radical form. Okay, whoa, too many radicals. There you go, done. All right, next one. Notice, 2 of my angles are the same. Because really, this is half of a square. Okay, that's a bad square. Let's make it prettier. Let's use the shapes tool, make a line. Come on, little cursor. Hold my shift key down. So this is really half of a square. Not the greatest square, but it'll survive. So 2 of the sides are the same. Pick a number, Ahmad, any number. 8. So if I pick 8, these 2 legs would be 8. This leg would be 8 square root of 2. It is that simple. But now I'm going to make it a little harder. I'm going to take the number Ahmad gave me, and I'm not going to make that the leg. I'm going to make it a hypotenuse. Okay. So this time, to get my leg down here, I have to divide by square root of 2. So you do the rest. Simplify that just like we did this one. Except you know we're not multiplying by square root of 3, right? Okay, you finish it. Find the length of the legs. They're both the same. Multiplying top and bottom by square root of 2 instead of square root of 3 this time because it's square root of 2. And that's 8 square root of 2 over 2. And 8 square root of 2 over 2 is 4 square root of 2. Okay? Won't get that much more complicated. All right. Find the missing side length. So you have the 2 special right triangles. Make sure you use the proper ratio in order to work it out. So try the next 2 pages. Okay. Find the missing side on both of them using the proper special right triangle. They are not interchangeable. Nope. So it's kind of like you're either going in a clockwise or counterclockwise fashion. But if you have the hypotenuse, let's see, clockwise is that way. So this is counterclockwise. I need to work through the short leg before I can get to the long leg. So short leg, 4, and then the long leg is 4 square root of 3. So it says, let's round. So just go to Desmos. Oh, we don't have Desmos open. Let's just go to Desmos. And type in 4 squared root of 3. Literally 4 SQRT3, and that will give you your answer. So 4 SQRT3, 6.9, because that's the nearest tenth, right? So approximately 6.9, which makes sense because my hypotenuse is supposed to be my longest side. 6.9 is pretty big, but it is 1.1 less than the 8. If my leg is ever longer than my hypotenuse, I did something wrong, okay? And vice versa, you know, if I'm trying to find a hypotenuse and it's shorter than one of my legs. Okay, hypotenuse is always the biggest. All right, find the missing side length. This one's a little easier because it's right next to that one. It's right next to the 60, so that's just 7. Now it gets a little more challenging because now we are going to start solving for missing angles. Okay. You should be able to do this without trigonometry. I'm going to show you the proper way to set it up with trigonometry because in the problem after this, which we're going to do next, you're not going to be able to use one of the special triangles. Okay. How do I know this is a special triangle?
8 and 16.
Yeah, because if my hypotenuse is double one of my legs, that makes this a 60-degree angle right here. Is that my answer?
No.
Yeah.
Well,
But if I ask for angle B, what's the relationship between A and B? Anybody remember the special name?
A and B.
Angle A, whoopsies, someone text box. Angle A and angle B.
Are always greater than angle C.
No, in fact, they're equal to angle C. Somebody said it. Complementary, okay. A and B are complementary, which means they have to add up to be 90 degrees. So if I find one, all I have to do is subtract from 90 to find the other. Okay? And that's always the case. Notice there's no I in complementary and math. Okay? It's not, you're a very good angle. Good job, angle. No, it just means they add up to be 90 degrees. Okay? Complementary. So complete, not comply. All right, next one's a little harder. Is 10 double 6? All right, so I'm going to do this one a little bit differently. So, angle N, right? So 6 is opposite, so I labeled it OPP. That's my hypotenuse. This way I know which trig function to use. Take a moment, don't say it. Just think it and write it using your equation editor. Okay. So take a moment and see if you can set up the equation that we're going to use to solve, and then I'll show you how to use Desmos to actually do the solving. So, equation editor. Off to the side. Adrian R. Which function are we going to use? Got 6 to choose from. Only 2 are right. Opposite hypotenuse. Sine, because S stands for sine. S-I-N. Ready? Capital N. This is what Cami does. It understands it's a trig function. So it puts a little space and makes it italicized. Equals 6 over 10. We're not even going to simplify it. You don't have to because we're not interested in the fraction. We're interested in the angle. So above here, type in the word inverse, trigonometric function. Because what we're going to be doing is not sine directly, but the inverse of sine. So remember back in the day, last semester, when I asked you to find the inverse of f of x, how did we write that?
The little minus.
A little negative. So we're going to do the same thing here.
I
So
remember this.
sin, shift 6, negative 1 of n, whoopsies, capital N, okay? I'm sorry.
Yeah, it's a little bit worse.
I'm sorry, flip these around. 6/10 equals, whoa, hello. So let's use parentheses here. Equals, and I'm going to be real specific and proper, little m, go back to your equation editor. We're looking for the angle symbol, which is in the 5th line down towards the end. Okay. Does anybody happen to know what the inverse sign of 6/10 is? Yeah, me neither.
Yeah, I got you right here.
So we're going to copy and paste, but just this left-hand side, and let's make that a capital N.
Yeah, it's only like
Okay.
points.
Into Desmos. And here is where you have to start thinking. That looks really small, doesn't it? Because that is not the right answer for the angle measured in degrees. So what? Yeah, so we haven't learned about radians yet, but we will soon. But the default mode for Desmos is in radians. So you simply select that, change this over to degrees, and there I got it. Okay? I'm going to round this off to nearest tenth. That's 36.9 degrees. Okay? So measure of angle N, measure angle capital N, approximately equal to 36.9 degrees, which was pretty close. And there's a degree symbol on the bottom here. Okay? To 30, right? Which makes sense because 10 is just a little bit less than double 6, so my angle should be pretty close to 30 degrees. That's it. We're done. We'll pick up tomorrow.
Yeah, my brain is really slow.